pH scale measuring by powers of 10. The concentration of hydronium ions ranges from about 10 moles per liter for a very concentrated strong acid to about 10 to the power of negative 15 moles per liter for a concentrated strong base. Okay, one opposite, to each opposite end of the spectrum on the pH scale. In 1909, a Danish biochemist called Sorensen suggested a method for converting concentrations to positive numbers. So, what we have here is pretty much what we're going to be looking at is a numerical system of logarithms. Have you guys in math done logs? Use the log key on your calculator? No, not yet? Okay, we're going to be doing it. I'm not going to go through explaining too much about really logs and logarithms. That's what your math teacher should be doing. Okay, and really all you need to know is how to put these numbers into the calculator. That's really what I'm going to show you guys. Real simple. These are really real simple calculations that we're going to be doing. So you're going to see it. Now, just to touch upon what your math teacher will be teaching you about logarithms. The logarithm of a number is the power of to which you must raise 10 to equal that number. So, the logarithm of 10 is, so what am I going to, so 10 is my base in the logarithm. What is 10 going to be to the power of that will give me also 10? 1. So, the logarithm of 10 is 1. Because 10 to the power of 1 is equal to 10. So that's what we're, just to kind of, just a recap, just to kind of give you guys a little insight about what logarithms. Logarithm of 100 is, again, same thing. What is 10 going to be to the power of that will give me 100? 2. Right? Because 10 to the power of 2 is 100. Okay, so far pretty simple, right? I think nothing too fancy. Sorensen defined pH is equal to negative log of H positive, right? The hydrogen proton. But obviously, if we're using the hydrogen proton, right? Remember Arrhenius, as we talked about at the beginning, was the one responsible for that theory, that the hydrogen dissociated, right? But he never took into account the fact that there was water, right? So we're going to rewrite the formula. This is now the formula you need to know. That the pH, to calculate pH of something, is equal to the negative log of the concentration of the hydronium ion. So regardless of whether you're calculating an acid or a base, the pH scale, remember, power of the hydrogen, how many of these, what is the concentration of that in solution? Right? If something is basic, still there are going to be some, hydronium ions, but not as many as there would be in acids. Right? The stronger the acid, the higher the concentration of the hydronium ion. Right? So, what does pH really stand for? Well, we're looking at power, right? Power of 10. Right? That's why we're calculating the logarithms. Logarithms is 10 to the power of something. Right? So what power of 10 to the something is going to give me whatever number we're looking for, the logarithm of something. And then H stands for the concentration of the hydrogen ion, but not really the hydrogen ion, it's the concentration of the hydronium ion. So what we're looking for is the actual concentration of the hydronium ion in moles per liter. Okay? Or capital M, moles, or sorry, molarity. So capital M, moles per liter, or in moles per liter. Okay, so you're probably panicking, going, "Oh my goodness, this calculation, it's gonna freak me out." It really is. It's really simple. So we're gonna look at. Let's look at the first sample problem. Calculate the pH of a solution with the concentration of the hydronium ion being 3.8 times 10 to the power of -3. Right? So how do I write this in the formula? So what is the formula? The formula is pH is equal to negative log and the concentration of the hydronium ion. So what I'm going to do in here is I'm going to substitute 3.8 times 10 to the power of negative 3 into this H3O. Okay, into the hydronium. And that's what I'm going to get. So I'm going to put that into my calculator. The only thing I won't be able to put into my calculator is that moles per liter. So let me get out the calculator here. I've got the following. So when we're putting in the calculation, let me just, I have the numbers because I don't have the numbers right now on me. So if we're trying to calculate, we hit the negative button on our calculator, right? We're going to hit the log button, right? Negative log, and we're going to put in the numbers 3.8, but we're not going to hit times 10, right? We're actually going to hit the exponent button, and you can see it here. You're looking for either the little EE on your calculator or the EXP. So you're looking for a button that shows you as EE or the button that is EXP. This will bring up some kind of letter as such, or maybe your calculator. And what really this means, what all this means here is the base of times 10. That's really what that little e stands for. And then we're going to put in the remainder, which is negative 3. Okay, because we've opened up the brackets. Okay, or it opened up the brackets when we put it in. Maybe your calculator doesn't, but if it did, close the brackets. Okay, and then hit equal. So there is our answer. 2.420216, and it goes on. Now, how many significant digits in my question? 2. So my answer should only include this 2.4, right? We're going to look at the number immediately following that. Will it change anything? No. So the answer is the pH is equal to 2.4. So what kind of a solution do we have? It's an acidic solution. We know from this, based on this pH level, we have our ammonium concentration, we have our hydroxide concentration. Is the concentration going to be equal, less than, or greater than? Greater than. So the concentration of the hydronium ion is going to be greater than the hydroxide ion.